Hello, welcome to the GATE 2021 Ce Set 2 question number 39, which states that a perfectly flexible and inextensible cable is shown in the figure where the external load of 10 kN and 12 kN are acting on the cable at a point F and G. We need to find the magnitude of tension in the cable segment FG. So we need to find the tension in this cable. The basics of this topic is given in NPTEL course Structural Analysis, Lecture 11, Cable by Dr. Devdas Maran of IIT Madras. Let us just directly jump into the solutions and eventually understand the concept too. So we'll start with this question by finding the vertical reaction at the supports, that is VE, HE and VH, HH. Though we will not need this reactions for our solution. Why? You will know later. So we'll use one of the equilibrium equation, summation of mh is equals to 0. We are taking moment about the point H. So what will it give? It will give a clockwise moment VE times 6, and this horizontal reaction will also give a moment which is anti-clockwise in direction about the point H with a perpendicular distance of 1 meter. So it will be minus HE times 1. This 10 and 12 is also making anti-clockwise direction. So it will be negative minus 10 times 4 minus 12 times 2 is equals to 0. So this will give us 6 VE minus HE is equals to 64. So we got our first equation. In order to find the values of VE and HE, we need one more equation containing these two variables. So as we know that in flexible system, since cord is flexible, the moment at every point, so moment at every section of cable is equals to 0. So from this we also take summation of MF is equals to 0 for part of left side, so as to calculate VE and HE. Okay, so this will give us VE into 2 is equals to HE into 3, and from here we can get the value of HE is equals to 2 by 3 times of VE. Okay, here comes the other equation. So by solving equation 1 and 2, we'll get V is equals to 12 kN and HE is equals to 8 kN. So we got our vertical and horizontal reaction at the supports. Now to find the tension in the cable FG, we can cut a section here and can then take this system out and can solve using equilibrium equation, summation of Fx equals to 0, Fy equals to 0 and Mz equals to 0. But this process will actually take time. Okay, so in order to escape from this time taking process, I'll explain you one more method named Funicular Polygon, and this is a very strong method to find the tensions at any section of the cable. Though it's your choice which method you want to go for, I'll recommend the Funicular Polygon for the competitive exams like GATE. So let us just quickly understand the Funicular Polygon concept. So here we have the cable profile in which this is point A, this is point B, this is point C, this is point D, and this is point E. This is vertical reaction at E and this is vertical reaction at A. We already know how to solve these VA and H, right, using the equilibrium equations. So how to draw a Funicular polygon? It's simple. First make a point O, and about this O draw the lines parallel to the cable. Okay, what does it mean? That here you can see T1 is moving like this, making an angle theta from the horizontal. So we'll draw T1 like this, which will be making the angle theta 1 from the horizontal. Again we'll see T2, which have the slope of theta 2, and theta 2 is having a slope lesser than theta 1, right? So we directly draw T2 here. Let me make this theta 1 a bit above so as not to cut the line. So here goes our line T2 with angle theta 2. Now we have T3 like in downward direction. So we'll draw T3 like this, okay, and then we have T4 with greater slope than T3. So we'll draw T4 like this, with the horizontals making theta 3 and this is theta 4. Now our polygon is being ready. We'll combine all this with a line like that, okay. In this polygon, from this horizontal to this topmost part is your VA and this is your VE. Now W1, you can see it depends on T1 and T2 cable, right? So here we have T1 and this is T2. So between this we have W1. So we can write this as W1. Now again you can see W2 is acting on the cable T2 and T3. So between T2 and T3 the load will be W2 and similarly this will be W3, and that's it. Also this thing is your H from here to here, horizontal reaction. So what's the benefit of this? So benefit of this is, in order to calculate the values of theta and tension in the cables, you do not need the value of height or length to a specific point. So let us quickly know how to calculate the values of T1, T2, T3, T4. You just need to know the Pythagoras theorem and that's all. So for T1 we will see this triangle. We know the height, that is VA, which is calculated using equilibrium equations. We know the base, and using Pythagoras it will be VA square plus H square square root. So similarly for finding the T2 we need this distance or value, which is the difference of VA and W1, and using Pythagoras we can write square root of VA minus W1 square plus H square. This will give us T2. Similarly T3 you can calculate, that is VE minus W3 square plus H square, and T4 that is VE square plus H square. Isn't it simple, right? So let's just quickly apply this concept over our question. So we found the value of VE is equals to 12 kilonewton and HE is equals to 8 kilonewton, right? Now let us draw the funicular polygon. So we have EF like this. So this is our EF, okay. So we call it T1, it will be much better. So this is point O. Then we have FG, which having the slope less than that, so it will be T2. Yeah, TFG we will say. This is TEF. Then we have the horizontal part. So in GH you can see it's going like this, making theta from the horizontal. So parallel to this we will draw GH. So TGH. So our polygon is ready. We'll combine this like that, okay. Now we know that this is your VE, right? This is your HE, this is your VH. We can see this 10 kilonewton is at EF and FG cable. So this EF and FG, between this is the value of this. So this will be 10 kilonewton, right? And 12 kilonewton is acting on FG and GH. So this whole will be your 12 kilonewton, okay. Now what we have to find? We have to find the tension in the cable segment FG. So for finding out the TFG, we'll use the Pythagoras theorem, in which we will need this distance or value. So we already know VE. From VE we will subtract 10 kilonewton. So VE is your 12. 12 minus 10 is your 2. This will be your 2 kilonewton. HE will already know 8 kilonewton. So it will be 2 square plus 8 square, and we'll get TFG is equals to 8.246 kilonewton. And that's all. You didn't even need the height, only to find out the value of tension using the equilibrium equation. You just drew the polygon, used the Pythagoras theorem, and got the answer. And that solves our question. Thank you and keep learning.